All right. So yeah, last but not least, and in Germany we have a saying, I don't know if you can really translate it into English. The last one is to be bitten by the dogs. Not sure if you can really say this in English.
You'll find out.
And yeah, what Mario has said, it's the last presentation for today, so it's us between now the coffee break. So we try to hurry up. I think we're a bit behind. Welcome. So this is the last presentation. Together with me, we have two gentlemen really coming all the way from Texas, Austin. They flew in here to Denmark to really joining you guys here. We've been here yesterday for the partner event. Today we're here for the Data Center Consultant Day. So together with me on stage is Mario Conti. He's the VP of Engineering of Midas Immersion Cooling. And there in the back, the handsome gentleman over there is John Griffiths. He's a sales manager for the EMEA region. Yeah. So we will really look into liquid cooling and why liquid cooling as such is really helping the data center industry, or how really the sustainability of the data center side can be improved. And liquid cooling, as we all know, there are two things you can do. Yeah, if the density in a rack is increasing, you need to change something really from air cooled to liquid cooled. And whether it's direct to chip, cold plate cooling, or if it's immersion cooling, whether you submerge the server in the dielectric fluid, really to cope with that heat in the servers. So we will kicking off. So Mario will take the first slides, and then I'm jumping in with liquid cooling information, but also providing some information when it comes to new trends, technologies, and innovations. So like Seppo, I've also been at the OCP Summit last year and this year. So I have also some slides when it comes to what's happening with AI, how do an AI data center look like, and what needs to be done in order to reduce the energy consumption there. So yeah, Mario, all yours.
Well, thank you, and I'm very glad to be here. Before I start with the actual slides, I just wanted to paint a picture of where we are, stuff like that, and I like to start with Moore's Law. And as I'm sure most of you are aware, about in the 70s, Moore observed that the number of transistors in a chip doubled every 18 months. We've adjusted that to about every 2 years now. But effectively, that means that computers get twice as fast every 2 years. That's kind of a weird way to think about it. So I like to translate that into growth rate. So you have a supply mechanism that grows at 41% per year. Any other industry in the world, if you had your supply means increasing and getting more and more efficient 41% a year, it would be solved. We would not need to do anything ever again. That would be enough for anything, not data centers. That is barely keeping up. Depending on who you ask and what metric you use, data, compute, whatever, it doubles about every 13 to 18 months. That is somewhere between 60 to 90% growth rate every year. So Moore takes care of 40%. We still have the difference between 60 and 90, and how we do that? That is up to us, right? That is the data centers. We need to grow our capacity. We need to put more computers, more data centers, more everything in order to make up for that difference. And we are in a very critical intersection in the moment, I believe, because on one hand, we have AI. And I don't know about you guys, but I don't see that growth rate of information and compute slowing anytime soon. So it's probably only going to grow from here. It takes some authors several years to write a book. Now you can go to ChatGPT and get it done in 8 hours. So you do that, but that growth rate is going to increase. Data centers already are consuming about 3% of all the power in the world. So it is already a huge tax in our resources, and we're only getting started now. On the other hand, it seems like Moore's Law is already getting to its stop. I mean, the science people out there are concerned that now the transistors cannot get any smaller because we're getting to the size of the atoms. What's going to happen in the future? We might not be able to depend on Moore anymore. We might be able to data centers, and then we might need to grow at 60 to 90% in order to keep up with demand. That is going to put a lot of challenges in our industry, and I think we need to look at ourselves and do a very, very thorough analysis. And can we improve? How can we improve and make those steps? So I think now I'm ready to go to the next one. And if you look at data centers, obviously data centers are very power hungry, they're large, they're noisy, there is a lot of stuff going into data centers. And when we make this analysis, we identified that one of the main reasons why, or one of the main limitations for this is air. Air is a terrible heat conductor. We use air as an insulator just as often as we use it as a heat transfer medium. So we need a lot of space for duct work, we need very cold temperatures. It limits us in many, many ways. So what we figure is, why not change air with something else? Can we use water? And water is great from heat transfer, but it's also horrible in electricity transmission, so we don't want to use that. We use an electric coolant, many different options. I mean, it's not something that we make, but there's a lot of options out there. And by doing that, we are able to have a lot of flexibility. I mean, we can use warmer fluid, we can go higher density, a lot of power savings. I mean, it really allows us to, it's a very, very limiting factor right now. We take that away, it opens a lot of doors. So we say, if you, a standard data center, you switch from air to immersion, you get 42% power savings, 51% capex, and 60% savings, and space savings. Oh, that seems pretty big numbers. How do we get to those? And if you go for the next one, let's pick a couple of different PUEs, 1.55 for the global average, or 1.35 to a high efficiency one. There's a couple of things that get ignored. Is servers have fans, and fans are very, very, very power hungry. In some cases, up to 25%. So if you think about that beautiful container out there, you're wasting 25% of that capacity in fans. 15 to 25%, that is a huge overhead that we're just assuming it's part of the server. Doesn't need to be, and it shouldn't be. You remove that lowers your base, and then after that, you start getting some efficiencies from PUE because of immersion cooling. Instead of having 1.55 or 1.35, you go to 1.05, and we've measured this. We can justify that number, and your power consumption for a standard 1,000 watt server, it goes from almost 1.5 kilowatts or 1.3 to less than a kilowatt, because we remove those fans, and then we also have a very, very efficient cooling system. Again, we're only assuming 15% for the fans, which is a pretty average conservative thing. It could be, savings can be larger than that. The capex, a lot of it depends. Well, your power infrastructure gets reduced because now you're not wasting all that stuff. Your generators or all your UPSs, no more. They don't need to account for your fans, stuff like that. No cracks, no air handlers, no raised flooring. You really simplify an installation, and that can save you a lot of dollars at the beginning. And of course, if you get to the next one, space as well, right? I mean, the global average, you're talking about 8 to 12 kilowatts per rack if you're generous. We're talking about 200 kilowatts in some cases, a megawatt. I mean, we don't know where we are, but immersion gives you that flexibility, putting a lot of stuff into a very small area. So you can save a lot of space doing so. If you can go to the next one. So again, I don't want to bore you guys with a lot with the immersion. Obviously, I'm pitching two things. So one of them is really just a change from using air to actually going and moving to a liquid. But obviously, not all immersion is done equal, and we as a company, Midas Immersion, we've spent a lot of time making sure that we take all the advantage of immersion cooling without any sacrifices. So for this one, the other thing about immersion is, we remove the fans, which are the number one failure components for all the servers. There's no corrosion, no noise, no humidity. We eliminate the temperature swing. So basically, all the major issues that you find today go away. If you can go to the next one. So going to our system specifically, we have one tank and the CDU, cooling distribution units. We put two of those in the back, so they're fully redundant. We have them hot swappable, so if one of them is running, if the other one goes down, you can take that out, and an untrained person in less than 10 minutes can take one out, put one in, and go back to full redundancy without anything ever noticing. So John has been with the company for about 3 weeks, his second day in the office, we had him to take a video and go change it, and he did it. So it's so simple, even a salesperson can do it. We have flexibility. We can do one end, two ends, stuff like that. So it is made to be used and made to be easy to provide. I mean, when we started, we were a data center ourselves, and we developed this technology for our own use. So we didn't want to make it complicated, right? Because we knew that if we make it complicated, we're going to have to fix it. So we spent a lot of time working on how do we make this simple and maintainable and have that TCO as low as possible. We've been in business for about 13 years. We have deployed about 450 megawatts worth of capacity. Most of that has been in crypto. Obviously, there's not a it's still a slow industry in this case for data centers. I mean, it's a new technology, and as we know, we're all very conservative, and we want to make sure that everything works. But we know it does. We just need to convince you guys, and we are in this evangelization stage where everything sounds great, but you really need to see it for yourself. So we are willing to offer you systems for you guys to try, and if any one of you has a data center, a showroom or something, and would like to give it a try, we'll be more than happy to collaborate and have you guys try this system, because we believe this is the future. We might be early, but if we're not early, we're going to be late, because once it turns, the benefits are so great that it's going to go from here to here immediately, right? It is. I think the only thing keeping us at bay is just public incredulity. It is a great technology. It's just weird, and I think that's the last for me. Oh no, well, we have some different applications and different types of things. We have a small tank at 12U, great for small class XPOC, stuff like that. The 50U is basically a rack unit. That is our standard system that if you had 5 tanks or 1,000, that's how we would deploy. And then we can do stuff in containers, so you can pair it perfectly with your system. We just put one of our computes, one power distribution, and then a cooling unit, and then that's it. You have a full system. And of course, then for heat recapture, that is something that I've been wanting to do for so long. It's just I live in Texas and nobody wants heat for anything. So, and now I think I'm done. Yes.
All right. Well done. Good job.
Thank you.
Where can I buy these tanks? All right. Do you continue clicking?
Yeah, no.
Any questions directly to Mario? Of course, we are still around, and also afterwards, we're still here for questions. You convinced me what I said. I will buy one of these tanks.
There you go. I'll bring a checkbook.
Could you,
Mario.
Thank you very much.
Do it now.
Thank you.
Could you please click to the next slide?
No. And then just to say here, this is actually what we talked about. This is the future data center we see here. Then the facility management will be the white space in the future, because we cannot reduce it as much as we can with the data center. Good. Yeah, next slide there.
Thank you, sir.
And next.
Mario, can you take control there?
I can.
This one.
Yes, please. Let me double check here. They're not fooling me again, So basically, liquid cooling as such. So if you look at this slide, really comparing, let's say, a legacy traditional air-cooled rack with a liquid-cooled rack. And we're just looking at the space needed in comparison to those two setups, looking at the space needed per IT capacity is really kilo per kilowatt is needed. And you look at the old legacy one, you need space in the front for the cool aisle, in the back for the hot aisle, at the bottom, for the raised floor, and of course on the top for the ceiling. Altogether per rack, you need 15 cubic meter of space. If we look at the other side, the liquid cooled rack, 7 times denser. You need 3 times less space. And if you look at the overall building space needed for this kind of setup, it's 20 times less. It really also what is needed per kilowatt IT capacity. Next slide, please. And we take the same exercise, looking on the server level, and looking at the facility water also needed for these two setups. Again, the old school legacy server, air-cooled. You need 20 degrees of facility water provided by the mechanical cooling system in that data center site to come up with 20 degrees air-cooled flow in for the servers. And also what Mario mentioned, just think about the high-performance new AI servers, the energy consumption for the internal fans in those servers can rise up to not actually 25, up to 35%. At the same time, if you look at the liquid-cooled servers, there is no fans. There are no fans. And they can really use 40 degrees Celsius of fluid coming in there. It's really great there for all components in that server, for the heat rejection, and the conditions to making use of the excess heat is really ideal. Next slide, please. So now I would like to really show the whole picture. You can see here on the right-hand side, this is what we all know. As you all know, at the moment, 99% of all data center sites are still air-cooled. Yeah? What Mario said, yeah, it's still a niche, but we are really confident the tipping point will be really close. And when this is happening, yeah, because we have all these AI applications, it will scale big time. Yeah? So on the right-hand side, we all know this setup. We're comparing really in that slide 130 air-cooled racks in comparison on the left-hand side, 26 racks air-cooled, providing the same compute. Yeah, the same compute can be achieved with these different numbers. The air-cooled side, you can already see here from the numbers from the slide, it's 400 kilowatt less because of the missing fans in the servers. Straight away, 400 kilowatt are gone. At the traditional legacy setup, you will need 800 kilowatt for the chillers, for the air chillers, for the cooling towers. Really, this is 40% goes into the IT load there. You also need UPSs, of course, for the setup. Yeah, you can see here legacy is 200 kilowatt you need, and the other side is 100 kilowatt. If you're really comparing the whole system, the energy difference of those two setups is 1.2 megawatt. 1.2 megawatt less the 26 racks liquid cooled in comparison to the 130 racks air cooled. This is 40% less needed for the new setup liquid cooled. And as a consequence, if you translate this as in theory, if all, let's say, all data center sites would switch to liquid cooled, you can really reduce the energy consumption by 40%. So actually, with that number, you can really use the existing energy grid without any further investment, without extending the existing energy grid. So Marie, this is probably something good information for you coming from a utility company. So this is what is really how the impact would be if there is really a shift to liquid cooling. Next slide, please. Okay, now some innovations, what's happening in the industry, also looking a bit in the future. This is something we have been also promoting since a while. When I say we, it's not only me as an independent consultant, it's my business partner, David, known as David Junesaran, but also our network of independent consultants. These are underground data centers. As you know, the big challenge we have in the industry is between size and place. All the big data center sites are built outside in the middle of nowhere on a green field, right? So if we are promoting making use of the heat from those sites, it's not possible, yeah, because there is no user taking that heat. It's in the middle of nowhere. There is no district heating system. So the solution would be why we are not building data center sites really in the city center underground. Yeah, because then, of course, it's like an underground station, yeah? We call it like a tube or like a big cigar there. There are different layers. I think there are 5 layers. They're different size. It's also scalable, starting with 3,000 racks until more than 5,000 racks. And then on the surface, you have users taking that heat. You have buildings. You have shopping malls, kindergarten, schools, you name it, public swimming pools, taking that heat from that server. And then, by the way, if you also click on the next slide, please. The cooling and the heat reuse solution, this has been designed by my partner in crime, by David G. So he has designed this, and yeah, we think it will be picked up in the next future. There is a project now in Geneva in Switzerland. What is missing now, we need to have someone really doing this. We need to have, let's say, some of the hyperscalers going for that. It also depends, there are more implication and parameters needed. Probably it's too detailed now, but of course the structure of the rock is also needed. There needs to be really some analysis done, if this can be done and so forth. Seppo is still not convinced. I know this. We had a call already. But this will come. This is my humble view. And then if you click on the next slide, please, Henrik. This is also what we are pushing. Yeah, really. These apart from the underground data center, really those subsea data centers, which can be used offshore and onshore, especially. So we're pushing especially onshore. So let's take about all the rivers, the internal harbors, lakes. You can really drown those containers, which have also like a high performance cluster inside there. Which one of these containers, there's easily 1.3 megawatt, can also be extended, and you can also have several connected. So let's say all the big capitals are really located at rivers historically. Yeah, the River Thames, London. We have Cologne and the River Rhine, Frankfurt, at the Main River, and so on and so forth. So you have a river, you drown this stuff, you're making use of the excess heat, and you just leave it there with the latest equipment for 2 or 3 years. After 3 years, you lift it up again, a new container in, suck, and then you're using that excess heat also for the building, also industry building located at these rivers, harbors, you name it. So we can also see there's a big potential around this. We know the company is a US-Norwegian company who's doing that. So if you would like to get in touch with these guys, we're more than happy to support you there. Okay, next slide, please. Okay, no presentation these days without AI. We mentioned it at the beginning. It's like a buzzword since 2 years. And for 2 years ago, some of my friends said, yeah, AI is something they came up with now. Because 2 years ago, Silicon Valley, they had an issue now. And they came back, what is the next big topic? It's AI. But yeah, it's happening. We all also using, GPT has been mentioned. Also already, it's part of what we do already in our life. Also, I use ChatGPT to do some content stuff, you know. I can confess. But if you go to the next slide, please, Henrik. And Mario mentioned this. I mean, as we know, we love the industry. The pace is extremely fast. It's accelerating like big time. Just this latest chip, which has been revealed at the GITEX in Taiwan and Taipei. This was 2 or 3 months ago, maybe even longer. I cannot remember. But it's 30 times faster than the previous generation. And they say the TCO and the energy consumption is 25% less, just as the previous one. Yeah? So it's increasing, it's there. And if you click on the next slide, and this is almost, I think, the last slide. This one I've nicked also from someone from the OCP. His name is Andy Bechtolsheim, American, but his name sounds a bit German. I'm not sure, probably has German roots. He's one of the co-founders and a board member of the OCP Foundation. And I think, I will not read out what it's all about, but I think the important sentence is the last one. The area of liquid-cooled data centers has arrived with AI. And the development is as such. It's parallel. So you have, let's say, you have the air-cooled data center sites, the co-location sites. Parallel to that, the AI data centers is in a process. I mean, it will not happen in the future. We are really there as we are speaking here. It will also increase. So there's a parallel development, dedicated data center sites only for high-performance computing. This is what's happening at the moment. And this is a slide from last year's OCP summit in San Jose, California. I think this was about it. Huh? Can you have a look? Okay, we are still around. Many thanks for your time. It's appreciated. You take care and talk to you soon. Thank you.